This review video is all about triangles, proving them congruent or proving them similar. You'll have 4 examples, and go ahead and split your paper into 4 and be sure to write your title. For example 1, here's our question. Which of the triangles must be similar? I want to remind you that the word similar means that the sides are in proportion, so the sides are proportional, and that the angles are congruent. And there were 3 different ways to prove that triangles were similar. And these similarity proofs were side angle side similarity, side 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 similarity, or angle angle similarity. And these were kind of 3 shortcuts to prove that 2 triangles were similar. Now for this problem, they've given us 3 options. We're going to go ahead and draw a picture of all 3 and see if we can prove one of these theorems. So the first one says A, 2 obtuse triangles. So let's see if we can draw 2 obtuse triangles. So here's one, here's another. I'm going to say that this one is 135 degrees, and this one is 150 degrees. Both are obtuse triangles. But that gives me 1 angle but not 2, so I'm going to go ahead and say no to A. I can't use one of these theorems to prove that the 2 triangles are similar. For B, I've got 2 scalene triangles. Scalene means the sides are all different. So here's a scalene triangle. We'll say this is 3 inches, 4 inches, and 5 inches. And here's another scalene triangle. I'll say this is 6 inches, 5 inches, and 7 inches. In this case, they have congruent bases, so they have one side that's congruent, but that's it. So again, this one is not sufficient to prove that they're similar. That kind of gives it away. It's definitely C, but let's just kind of take a look at it. So I have 2 isosceles triangles. That means that their sides are congruent, and the vertex angles are also congruent. So this would definitely be true. These are similar by side angle side similarity. For question 2, they've given us this diagram, and they said if AK is parallel to MS, I'm going to go ahead and make those lines. How could you prove that triangle RAK is similar to triangle RMS? Well, the first thing I'm going to do is show that these are parallel. And just looking at this picture, what do I know? If these 2 lines are parallel, well then I know that this angle is congruent to this angle. Those are corresponding angles. I know this angle is congruent to this angle. Those are also corresponding angles. And I also know that they share angle R by the reflexive property. I'm going to go ahead and draw these separated. So this is triangle RAK, and here's the big triangle RMS. Now if I put all those markings back on, and this is the 3, this is the 1 congruency, and this is the 2 congruency mark. The question is, how could I show that these 2 triangles are similar? Well, they have 2 angles that are congruent. Now, they actually have 3, but I only need 2 to prove that they're similar. So I would say triangle RAK is similar to triangle RMS by the angle-angle similarity. Now for our third question. Here it says, given that point E is the midpoint of segment CD, and angle 1 is congruent to angle 2, what can you prove? Now I'm going to start by taking this information and putting it on my picture. Okay, so E is the midpoint of this whole line. That means that this piece is congruent to this piece. They said that angle 1 is congruent to angle 2. And you know what else? I noticed that this is a right angle in the picture. They don't talk about it up here, but if this is a right angle, I know this one is too. Those are vertical angles. So now they're asking, what could I prove? So I'm looking at this picture. Well, number one, I can prove that this triangle is congruent to this triangle by angle, side, angle. Angle, side, angle. So one thing I could prove is that triangle ACE, okay, so this is this furthest point, so I'm going to start from B to then to the 1, so BDE is congruent to triangle BDE. I could say by angle, side, angle. Now after that, once I prove the triangles are congruent, gosh, I could say anything. I could say that angle A is congruent to angle B by corresponding parts of congruent triangles are congruent. And that's just because if these two triangles are congruent, then all their pieces are congruent, like these two angles that aren't shown congruent. I could say that these two parts right here, these two legs are congruent. So I could say, oh, AE is congruent to BE. And again, that's by corresponding parts of congruent triangles. Once you prove two triangles are congruent, all the pieces are congruent. Well, the only last thing that we need to show is that these hypotenuses are congruent. So last, AC is congruent to BD. Why? Well, you guessed it. Corresponding parts of congruent triangles are congruent. So if they ask me this question, hey, what can you prove? Well, I could say any of these. All of those would be true. I could prove any of those. Once I showed that the triangles were congruent, I could prove all of this stuff. Now for our last question. It says, are the measurements given possible lengths of a triangle? And a triangle has 3 sides, so they should give me 3 measurements, and they do. The question is, if I had these 3 measurements, could they even make a triangle? Now, when I say that, I mean, will it close? So for example, some triangles, if one of the sides isn't long enough, even if I tip this line down, you know, it still won't reach. It won't close. So there's this gap here. So this actually leads to a theorem. So let's move this kind of to the side for a second and write this down. So here's what it says. 2 sides of a triangle, 2 sides of a triangle must have the sum greater than the third side. Now here's what that means, that if you have a triangle like this, A, B, and C, somehow you must be able to add these up so that A plus B is greater than C, or maybe B plus C is greater than A, or maybe A plus C is greater than B. But you must be able to find one of these in order to have a true triangle. So this is an important theorem. It's the triangle inequality theorem. So let's kind of use this right now. So I'm going to go ahead and move us back over here. So my question is, are 2 of these sides, or 2 of these combinations, bigger? So let's check this out. Is 3 plus 4 bigger than 6? Well, let's write it down. Is 3 plus 4 greater than 6? Yeah, that's 7 is greater than 6. So A could be a triangle. Okay, let's try another one. Is 15 plus 15 greater than 30? Well, is 15 plus 15 greater than 30? No, it's equal to 30. Okay, what about 15 plus 30? Is 15 plus 30 greater than 15? No. And if I moved it around, I would just get this one again. So no, B cannot be a triangle. Okay, letter C. Is 11 plus 2 greater than 5? No. Is 2 plus 5 greater than 11? No. Is 5 plus 11 greater than 2? No. C could never be a triangle. It would not close. Last one. Is 7 plus 7 greater than 15? No. Is 7 plus 15 greater than 7? No. That means that the only one of these that could really be a triangle is A.